And now, the moment you've all been waiting for, we are going to finally reassemble this carburetor. I got all the parts today. I was waiting for one part directly from Japan, and it was this. This tiny little clip that I lost. Yeah, not so proud of that. Righty then. So here's our float, our bowl, our old bowl gasket. We've got some other miscellaneous crap here, and I've got, this is the old needle valve and seat. I've got a brand new one we're going to put in. Okay, let me go find that. So these needle valves do not have nitrile coating, a nitrile coating on the tip. Actually, the original one wasn't really in bad shape at all. That was a very expensive part, I might add. Cost a little more than I was expecting. So this just drops right into here. There we go. You don't want to ruin that new seal, so you want to put something that won't affect the seal. Actually, I'm going to use a little bit of 2-cycle oil. That'll work. Won't hurt the seal, because guess what? The rubber that's used is supposed to be oil and fuel resistant anyway. So we're going to just put a little bit of 2-cycle oil on there, and it will just make it a little bit smokier on startup, but that's okay. That's just fine. So that should just slide right in there. Oh yeah, perfect, like a glove. Nice and tight too. The original one, the seal was so bad that it just kind of floated around in there. So now we've got to pop in the retainer clip. This is the one part that has been kind of holding me up. It took almost a month to get it in because it was on national back order. And I'm sure they saw that order come in and they're like, what the hell? Who in the United States is putting one of these stupid things together? There's not a lot of these in the US, it seems. This particular model appears to be quite hard to find in the US. There we go, nice and tight. Now let me check one more thing real quick. I want to make a quick note for you guys who are about to embark on a project like this yourselves. You're going to find that when it comes, if you have a question about how something is assembled, you're going to find more information not in the owner's manual, but in the parts explosions that you'll find on your parts suppliers' websites. I had this one gasket, I forgot where it went. It's a little fiber gasket. It actually goes to the bowl drain plug. And I had no idea where it went. Now I know. I actually thought it went to the main jet mount thingy, but no, it goes around this screw here, like that, and that's to prevent your needle valve from your drain from leaking. So we're gonna put that in. It looks like the original one might still actually be in there. Yeah, what's left of it anyway. So we'll clean that out and pop this back together. Oop. Almost lost it there. We're good. Put this back in and seal it up. Just want to do that before I forget, you know. For those of you who didn't see the original disassembly video on this carb, it was actually pretty clean. I took it apart. There was a lot of debris. The jets were totally clogged, and that I attribute to the early demise of the engine. I attribute the early demise of the engine to that. I'm not changing any adjustments on the float. I'm just going to drop the needle valve right in there. You'll notice that these needle valves have little spring-loaded tips. Those tips should move nice and freely. And that's to keep tension between the valve and the float so that they work nice and tightly together. The original one, I think there was a problem with that. No, actually it works. So, that original valve was fine. It really was. But Suzuki doesn't sell the The needle valve seat O-ring by itself, you have to buy the whole assembly, so I figured why not just replace it all. And we're going to precariously drop this sucker back together, throwing our float pin in place. Nope, almost. And there we go. So you can actually test it, make sure that the hold it in the air. Then just look at that valve, make sure it all moves nice and freely, goes up and down nice and smooth. And it appears to. When the float is in the up position, it should close that valve. And it does. It does a nice job of it. We may need to make some adjustments, and to adjust that, all you do is you bend this tab that's at the fulcrum of the float assembly. So it's real easy to do. So, okay. At this point, it's time. It's time to close the bowl. The key is with these carburetors is cleanliness. You don't want corrosion. You don't want sediment. You don't want anything in these carburetors in the passages. You want to make sure that's all cleaned out. And I suggest using an ultrasonic cleaner. You want to make sure that all gaskets and seals are replaced. By this point, any carburetor that's over maybe 10 years is going to need, at the minimum, a complete disassembly. And thereafter, once you get them running, it's not over. You have to continuously, every couple years, tear them apart and clean them. It's not a, just put it together and you're done kind of thing. It's a never-ending story of, endless repairs and rebuilding. Just to keep them at their optimum performance level. In the case of this bike, it ran actually pretty well. It seemed to. It had no power, but it was being starved of fuel, which in turn starved it of oil. Because the oil and fuel have to mix together so that the oil can flow around nice and freely, but not if the thing's clogged and running lean. It doesn't work that way. So, yeah, could have saved a lot of aggravation if this thing had been maintained properly. But that's why I make these videos. So some of you guys, gals, who don't have the level of experience that I do in working on small engines and stuff, now you can learn. It's not that hard. Anyone can do it if you put your mind to it. Really though, it's true. Anyone can do what I'm doing. You don't want this too tight. You can strip these threads out very easily. And you can also cam out the screws, which means when you have a screwdriver that doesn't fit properly and it starts to twist out of the screw, it can ruin the screw head. It's not funny, not fun, not cool. Bad stuff happens when that happens. Alright, anyway, I'm going to shut my mouth. So, what do we have here? I've got two brand new carburetor mounting bolts. The original ones were ruined by the previous owner. I'm going to blame the previous owner for that one. I don't know what that goes to. It's got a funny taper on the end. I don't know what it's for, do you? I'm serious. Do you know what this goes to? Because I don't. This spring actually goes inside here. And this valve goes in there as well. Actually goes the other way around. This little valve here gets attached to the enrichener valve cable, and then the spring goes in. Boom. Then the cap goes over that. We'll look at that in a minute. That'll be part of the mounting process. Ooh. Turns out these screws are actually for the carburetor mount. I don't know what those other screws are for. I'm going to have to figure that out though. So let's get our cables hooked up. I'm going to start with our throttle cable. Yeah, there we go. Alright. So we want to put this rubber boot on first, like that. Then the cap goes on. You can't see what I'm doing, can you? There we go. The cap goes on. Rubber boot, metal cap. There's a seal in there. Life is good. Cable's good and tight. Then the springy dingy. One springy dingy. Two springy dingy. And I got the camera out of aim. Alright. And that just kind of goes in there. Trying not to bend this valve, for Christ's sake. What are you, stupid? Don't bend that valve, ever. That valve is your friend. Yeah, there we go. And that whole thingy there, it just kind of goes in the carburetor. There's a groove to guide it along the way. There's the groove. You can't really screw this up. Well, you could, but you'd have to try. And that's the kind of trying that you just don't want to do. So when this is all threaded down, you don't want it too tight. And that's how it all goes together, my friend. Although there's some play here. A lot of play. That means something is out of adjustment. Like big time. We've got our cold start valve, idle or enrichener valve. You got to put that in, and it just slides in like so. All right, yeah. There we go. That just kind of goes in like that, and that threads in to here. So we just drop this little plunger right into the carburetor, like so. And then that just threads in. We're going to snug in that. Snug in? Is that? We're going to snug in this up with a wrench. And just a wee bit. There we go. That's pretty much it, guys. I mean, it's not rocket surgery. There is a dent, like a little impression or punch mark in the throttle slide. We're going to raise that up to the top of the bore, like that. Not sure if you can see it. We're going to raise that to the top of the bore, just so it's touching the top of the bore, and we're supposed to align the oil pump index mark with that. So I'll show you what I mean. We have to take our oil pump cover back off. Notice how the new oil pump cover is gray. They don't make the white ones anymore, but I kind of like it. It looks nice. It looks prestigious. Sure, why not? Alright. There is a little indentation, a little punch mark right here. So what it wants is it wants the throttle and the oil pump position to be in relation to each other. So I'm going to look at the carburetor and compare my punch mark to that, and it looks like I'm going to have to back off on that adjuster just a little bit. Right now it'll basically feed way too much oil into the engine, so I'm going to kind of back this adjustment, actually put it in more. Alright, at this point we could probably start hooking up our fuel lines and get that all done up. And just like that, Bob's your uncle. So I need to shorten that, and I need to obtain some hose to use as a bowl drain, and I actually think I might have something that I can use for that. I actually have a lot of extra oil line hose, which is about the right diameter for that. So I'm going to shorten this down. I'm going to add a drain hose that will be routed through here, There you go. I've already gone ahead and filled the oil reservoir, because why not? And we're going to bleed the system by loosening up this bleed screw. And let the blue gold, there it goes, until there's no more air bubbles in there. You can hear it. There it goes. Alright, so that's bled. Now we're ready to start the engine. Okay, got the exhaust on. We're going to do our first startup. Haven't started it yet. Put the exhaust on, put a little bit of this true fuel in there. Let it sit for a couple seconds so the fuel can run its way into the carburetor. See what's going to happen. Here we go. Looks like our idle speed's a little high. Alright, I had to put a board under it so the wheel can spin freely. Seems to be a common issue with these things. Here we go. Shut off. It was auto igniting, so it's running way too lean, more than likely. I had everything shut off, the ignition switch and the kill switch was both off, and it wouldn't die. Well, I just cut out a lot of painful to watch footage from that engine start section. Something went very wrong, and we're going to talk about that right now. So when I first started it up, it was idling at like full throttle. I mean, it wasn't quite full throttle, but it was like 75% maybe. I knew something was up, so I shut it down. I checked the idle speed screw, pulled it out a little bit more, started it back up again, and it made no difference. Same with the idle mix. Wasn't really panning out either. I looked around, I couldn't find any obvious intake leaks. I knew something was up. So I went to go shut it off towards the, I'm trying to shut the engine down, and what happened was I hit a point where the engine started dieseling. Because the throttle was wide open, and there's no like fuel cutoff solenoid or anything, the engine wouldn't shut down. It was running on its own heat, just like a diesel engine, just like a model airplane engine. This can happen, and it happened, under a series of certain circumstances. One thing that can cause that is a massive vacuum leak. Number two, a lean condition. The fuel ignites too easily when it's lean. There's a few other factors. I've heard of even a leaking head gasket can cause that too. But in my case, I attribute it to the fact that the throttle is stuck halfway open. And so I figured out what that was. It turns out the slide valve was actually not closing all the way because the cable end that goes from the throttle to the slide valve was out of position. It must have happened during the reassembly of the top end of the carburetor. Obviously, that's when it happened. That situation has since been resolved. It now idles nice and smoothly. I didn't start it up on plain gasoline. No, I started it up on True Fuel. It's a 40-to-1 ethanol-free fuel. You can buy it at any hardware store. It's expensive. I think that probably about a quart or so of fuel cost me like $5. So that's about $20 a gallon. It's pricey. But it worked. It protected the engine for its initial startup while the oil pump, you know, started getting itself worked out. At this point, I believe the oil pump is all up and running. So that all took place. We had a dieseling condition. Now, you can't just start up a brand new engine like that, full bore, and expect nothing to happen. Because what happens is, number one, the engine is cold. Number two, the engine is not broken in. So what happens there is the piston heats up faster than the bore. And because the bore is heavy and cast iron, while the piston is just a little thing made out of an alloy of some kind. So it heats up rapidly, where the bore doesn't have a chance to get up to operating temperature. And for those of you who know what I'm talking about, yeah, it's a recipe for disaster, because that piston is getting bigger, the bore is not. Engines are built with a certain amount of tolerance for that kind of difference in expansion. But a new engine is not, because nothing is broken in yet. There's not enough space for that to occur without serious consequences. So that piston began scuffing. And oh boy, did it begin scuffing. So I didn't notice that until I tore the top end apart to check the ring gap. By the way, thank you to the YouTube viewer who mentioned the ring gap to me, because I wasn't thinking I needed to adjust the ring gap on a brand new motor. It wasn't. I thought everything would have been taken care of at the factory because it was a kit that I bought, right? No. They did not do that. That's my job. So I, at that point, once I had it all apart for inspection, I did check and adjust the ring gap. And yes, it was too close. The top ring was so close, I couldn't even get a feeler gauge in there. So that's all good. We're gonna show you how to do that at the end of this video, and what the end result was. But yeah, that could have ended very badly. If I had not used a premix, the engine would have seized. A lot of things could have happened. Worst case scenario though, and this is the sick thing about this little two-stroke engine, that would have cost me $140. Now, you do that on a car engine, you do that on a more expensive motor, a Harley or whatever, you're looking at a lot more than $140. Now, anywho, so yeah, I mean, there's a lot of things that can cause a two-stroke to race, and definitely intake leaks are one of them. If there's an intake leak, or even a crankcase seal or a crankshaft seal, can cause the same thing, because a two-stroke draws its intake air and oil mixture through the crankcase. If there's a leak on either side of that crankshaft, it can cause the exact same problem. It can start to race, and because you're drawing in air that is not accounted for in the mixture, it'll run lean. You get more air than fuel than needed, and it will run hotter and make your day even worse. There's just no good end result there. That's why we were so thorough in rebuilding that engine. I want to talk about one more thing before we move on to the ring gap. I've got the fuel tank off. I've got the fuel hoses all removed. The petcock has been. I went through the petcock, tore it all apart, checked it over, and I did some of my own little vacuum tests to make sure the vacuum valve is working correctly and make sure that there aren't any leaks. And it seems to be in pretty good shape. I am going to order some new seals for that because I found that the main valve seal is a bit chewed up from age. So I'm going to order a new one. It's not that expensive. The fuel tank is getting some rust treatment. There's a little bit of rust in the tank. There's not a lot, just a little bit. You probably can't see it with this lighting, but I'm going to go ahead and just soak it in Evapo-Rust. I'm going to fill the tank with that stuff, and you know, Evapo-Rust will remove the iron oxide and leave a nice gray coating over it, and hopefully it won't flash rust. I've decided not to do the cream or red coat coatings because it's an expense that I don't really need right now. It can be done later on, and it's easy to do. But I am going to repaint the tank completely with Rust-Oleum Cherry. I actually ordered a catalog from Rust-Oleum. They sent it free. They don't charge for these. And this gives you a list of every color they offer. And I found that this cherry red is a very close match to the original red. And I think 1 can of cherry red will take care of the fuel tank, and then I'm going to top coat that with 2K clear, which is something that I can get from either Eastwood, or there's another company that sells it. It's a catalyzed clear coat that is fuel resistant. So if you're painting a fuel tank on a bike or whatever you got, that 2K clear should take care of the fuel resistant properties. Because if I just go ahead and paint this with Rust-Oleum, the first time I fill it with gas, it's going to destroy the paint, because even the vapors from the fuel can cause the paint to soften and come completely off. So that'll take care of that, and it's going to look pretty decent. I'm going to use that same paint on the headlamp housing, and there you go. There you go. It's that simple. So let's talk about ring gap next, and hopefully some of you have learned a few tidbits on how two-stroke engines actually work, and why it's so important to make sure you have no intake leaks, and assembly issues can cause you some major problems. So I decided to remove the cylinder and piston just to confirm some stuff. I want to make sure that my piston ring end gap is within range, and I still need to figure out what that is for a cylinder of this size. The great thing about two-strokes, though, is they come apart like Lego bricks, and very quickly. So you can clearly see that we've got some scoring going on right by the exhaust port. There's a little bit of scoring happening here, and because it's so early in the game, you know, it's not like, yeah, there's another score mark here, and there's some scoring here. Not scoring, but scratching. But like I said, it's so early in the engine's life that you know, things haven't had a chance to go really badly. So what I want to do is I'm going to check my piston ring end gap, and just make sure that the issue isn't the result of piston rings binding up, because that can certainly cause the scoring that we're seeing. And that's basically the result of poor or improper end gap. So we're going to go take a look at how to measure end gap, because you know what, this is a new thing to me as well, and I'm sure some of you are green at building engines yourselves, and you know, I spend most of my time repairing engines and just doing basic things. This is far beyond anything I've ever done before. So I'm going to just pop this ring right here in the jug, and we're going to measure its end gap. See how we're doing. And what you do is you put the piston, or the ring, right in the bore, and then, oh, we found the problem. Well, at least one. Check this shit out. So we have like no end gap. We have like no gap there. It's so closed up. So I can't even fit a feeler gauge in there. So that, my friends, is why you always measure your end gap when you rebuild an engine, because this piston ring is absolutely going to cause us some major problems down the road. Hold on, let me figure out what the specs are. Okay, we're going to measure the ring gap, and it appears to be 0.180 millimeters. And I prefer metric because it's just easier to deal with. I've always found it to be easier to deal with metric. 0.180. Let's see if I have anything like that on my gapping thingy-majogger. Not even that. Wow. 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 We don't have any ring gap. That's the problem, son. Fun for the whole family. Do the other side too. Remember, you can always remove material, but you can't add it back later. I think I'm going to do the .203. 178 is, yeah. Alright. It should be .80, I believe. .180 is our target. And let's, you're going to use the piston, right, to level it off. Now, obviously your ring gap is going to vary on a used bore. If you had a used bore, you would want to set your ring gap, I believe it's on the top, which is less worn than the bottom. No, vice versa. Yeah. Alright, where are we? We actually have ring gap now. Oh, wow, that fits in there. It didn't fit before. So, it looks like we've solved that problem. The .203 fits just fine. It can be too big, but having it too small, that's the thing, is having a ring gap that is too small can cause the piston to bind up, or the rings can bind up. It can cause the ring to expand into a port and get hung up and cause severe damage. So this ring is ready to rock. We're actually a little bit more than .203. I think we're actually quite bigger than that. Here's a .635 millimeter, and that doesn't quite fit in there, but we're much better off now than we were before. So that's our top ring. We want to make sure they get put back the way they came apart. And here's the bottom ring. I don't really see any major damage on these. I see a little bit of scoring here. And again, this is just superficial. I mean, the engine only ran for like maybe 15 minutes, so I don't think we're... This would have been a lot better if we had done the ring gap before assembly, but you know, what are you going to do? Can't go back and do it all over again, you know what I mean? Okay, this one looks to be like the first one. We have, again, no ring gap of any kind. It's pretty bad. So we're going to get our .203 gauge. Where'd it go? 0.3, 0.3, 0.4, up or ascending. Another rookie mistake that I made is I put these clips in wrong. They actually need to go in so that the gap in the clip is parallel to the piston's motion, direction of travel. Believe it or not, the velocity of the piston moving at high speeds can collapse the ring, causing it to dislodge. Did not know that. Now I do. I got that from an article on mopedarmy.com. And now we're going to reinsert the piston into the bore. Again, making sure that the piston is in the correct direction, like that. I'm going to once again coat the cylinder bore with 2-cycle oil. I'm going to use a brand new base gasket, as I do have a spare. So I'm going to use a new base gasket. I could probably reuse the original, or not the last one, but I'm not gonna. I'm just going to replace it with a new one. We do know that it's not a lack of oil. This thing is getting plenty of oil. There is no excuse for any lack of lubrication, unless there. Now, I believe some of this damage may have occurred upon the initial startup, which unfortunately was a almost a full throttle startup on a new top end, and that's really not good. We had an issue with the carburetor being improperly adjusted, and that is what caused that. So, okay. The ring was upside down. Didn't know that they were directional. I know some of them are directional, but I wasn't aware these were. Okay, now it's time to put this back into the engine and button it all back up. And that is why you're always supposed to check your ring gap, damn it! you could have problems. And again, the damage to the piston was likely from the full bore startup, which, not good. Not good. That was not good. So, whatever.